Hello students, welcome to EduCell. Today's session is all about iteration method, how to find time complexity using iteration method that we are going to read. And basically iteration method is used to solve a recurrence relation. Now you can uh, look at this part we are actually trying to solve the easiest you can say easy recurrence relation. Then we can go towards the moderate. Once moderate is well, then we go to the tough one. Okay, so first you can take the example of t of n, what t of n is and how we are displaying the things that you have already read in the previous video. Suppose the it could be like n by 2, simple one that we start from the simple. So here this is a function, this is the cost. Okay, this is function, this is cost, that in the previous video. Okay, and how to solve using the recurrence relation that we are using the iteration method we are going to read. Okay, to know first of all we should check t of n. We found t of n is t of n by 2 plus 1. Then what is the value of t of n plus 1? To know that one, we have to find the value of t of n by 2. Then we can substitute the value of n by 2 in place of n. Then n by 2 by 2, because I'm just substituting the value of n by 2 in place of n only. Okay, then keep as it is, the cost should not be changed. Okay, you keep the cost as it is. Next you go for the function t. I'm just writing it by expanding this. It's tn by 4. Again the problem arises, if it is tn by 4, then what is the value of tn by 4? If something is new, we are going towards it, but the target should be, we should keep the uh, if something we are getting is quite be like having some progression. Okay, if there is a progression, we should focus on that. Here you can check t of n by 4. I'm just replacing in place of n only. I'm not replacing in place of n by 2. Some students are actually doing the mistake. They are placing n by 4 directly there instead of n by 2. So it's a problematic. We are actually focusing on the tn. Okay, now I'm just putting the value of tn by 4 in place of n. Then keep the cost as it is. Next the value will be tn by 8 plus 1. This is what we are actually finding the pattern. Okay, the pattern will help us if it is running for suppose k times or n times or p times, not for n times, but if it is for k times p times, which is not equivalent to n but it is less than n times. Suppose we are running for it and we can expect the time complexity could be this much. Okay, that is what exactly the iteration method working. Now we are going to substitute the value. Okay, you can directly substitute here, or else you can directly put 1 1 1 1 at least for k times of p times. I'm just using a substitution kind of thing here. The iteration method, how it is running, you can check 2 plus 1. I'm just writing it. Now I'm putting the value which I got here. I'm just replacing it here in place of tn by 2. You can check tn by 2, the value is tn by 4 plus 1. Okay, then plus 1, which we kept as it is here. Next is tn by 4 plus 2, simple. Okay, or else if you want to keep a pattern, you can keep 1 plus 1. That could be a better pattern that we are expecting. Okay, next is to know the value we have already found, which is this much. You apply directly there, tn by 8 plus 1, and as usual 1 is common, which we actually do not touch this. Clear? Now you need to expand again. Tn by 8 plus 1 plus 1 plus 1. Okay, 3 times we are actually running for 3 times. Once we found it, you can simplify it, because I told you a pattern. If you are finding any pattern, we should stop there. So here, uh, for 3 times it is multiplying with the cost indirectly, like 3 times 3 into 1 I can write. Okay, 1 is constant, but don't text much idea about it, but just think how the cost is working. Okay, here the cost is 2. Instead of that, I can write, you can say, to simplify that, I can write 2 to the power 0, 2 to the power 2 there, plus 2 into 1 also I can write. Okay, like here also the same thing I can write, not an issue. Here I am saying done. So 2n square, instead of 4 I can write 2n square. So here you can check, we got a pattern. Let us think, running for k times, running for k times. Once it is running for k times, then what the value of Tn? Here is the problem actually arises. Here it's 3 and it's 3. They both are variable, and n we are not vary, we keep as it is, and the constant as it is. Which is vary that we have to look at here. Okay, n by 2 to the power k. If it is running for 3 times, you are writing the answer. If the answer is correct, we can say the formula which we derived is correct. Suppose it is running for, instead of 3 times, if it is running for 2 into 1 time, so we can say, for here is 3 and here is 2, means here we can say it's k minus 1. Okay, so that we will discuss in next video, because this is a easy problem that we are actually solving. I'm just putting the number as 1. Okay, so here the problem we found is this much if it is running for k times. But let us think, the base condition which we decide is, for this, the base condition we derived, suppose the base condition is t of 1 is 1. Okay, if t of 1 is 1, the base condition is decided well. Base condition, that the base condition is written for, like we are reducing the problem towards the base condition, because we know for t of 1 where n equal to 1, the value is 1, we know, and others the values we do not know. That's why we are trying to reduce towards the problem, towards the base condition. You will know in recursion videos, when you read the recursion video, that how the tree is exactly expanding, how it is reducing towards 1, because we know the value. That's why we are actually doing that one. For better example, मैं ये तुम्हें बोलना चाहता हूँ कि तुम्हें पता है, सपोज छोटा सा कोई मीनिंग हो, या कोई ग्रामर तुम पढ़ रहे हो, लाइक यू आर रीडिंग इंग्लिश, सपोज you know your original language, you know the base of it. When you are actually not understanding well, then you are actually focusing your target, like तुम बोल सकते हो कि तुम क्लास में नहीं समझ आ रहा है, या कोई कुछ भी बड़ा कोई टॉपिक आ रहा है, तो तुम ट्राई, यू आर एक्चुअली ट्राइंग टू सॉल्व इट, है ना? कैसे सॉल्व कर रहे हो? जो तुम्हें पता है थोड़ा बहुत उससे लिंकअप कर रहे हो, लिंकअप कर रहे हो मतलब तुम्हें एक्चुअली जो पता है उसके साथ तुम ट्राई टू कोलैबोरेट, कि हाँ ये हो सकता है क्या, वो हो सकता है क्या, मतलब यू आर एक्चुअली हैविंग अ बेस्ट। जो ऐसे बोला जाता है कि +2 में आ गए या इंटरमीडिएट में आ रहे हो, तो वेदर यू नो द 10th सिलेबस और नॉट, तुम अभी बीटेक में चल रहे हो या कोई भी, है ना? सो इफ यू आर रीडिंग एल्गोरिथम, you must know the DSA, data structures. So this is the base of it. Like you can correlating base is needed. If something is greater, so we are actually reducing our problem towards a lower one. ठीक है, जो जितना easy समझ आएगा, इसलिए हम examples दे रहे हैं. We are creating examples to make the thing easier to you. ठीक है, तो यहाँ पे तुम देख सकते हो, the problem is like we found is Tn by 2 to the power k plus k into 1. So here what exactly we are trying to find? We're trying to run it for suppose k times, and we found this much. But our main target is k times, means how many times it should run. Like like the number of times if we find, we can easily tell. Yeah, this is the time complexity that we read in it, the iteration method. Okay, there are two methods, one is recursion, another is iteration to solve a particular problem. In iteration, we are trying to find the number of times it is running. The number of times it is running is exactly the time complexity. Okay, so now you can check assumption. We say we have reached the base condition. Assume the base condition we have reached. Okay, where we said it's t of 1 is 1, the base condition. What exactly we are going to assume is the function n to the power to k is equivalent to our base condition. Next is the cost. What is the cost? The cost here is n by 2 to the power k is equivalent to the value. You can say it's a value better. Okay, within that. So you do not start with this. You first find the relation between the functions which you found. We say the function is reduced now. Once the function is reduced, the function you have to write LHS side or RHS side. It's up to you. And next, another side you have to write the base condition function. Okay. Once it is done, next what you have to do, we are trying to find the value of k now. Okay, that is why we are assumed that assumption we have taken on the basis of k times it is running and we stopped. Okay, by thinking everything is right. Now we are actually finding the k times. How? Here n is 2 to the power k. Next, to find the k value, we need to remove 2. To remove 2, but we have to use log base 2. You apply in LHS side and RHS side. Log base 2 to the power k. Next, as for the logarithmic property, k will be enough, though it's a power, it should be enough front. Now you can check log n 2 k log 2 base 2. Log 2 base 2 is 1 and k is equivalent to log n base 2. Now you substitute the value of k in equation 1. Okay, the equation 1 which we decided, now you substitute the value there directly and you'll get a time complexity. This is how the iteration method works. Okay, now I'm substituting the value. Substitute the value of k. So here t, within that though we reduced, again I'm just putting the value of k there, or that I told you 2 to the power k is n, so I'm just writing that one, n by n. Okay, as we as for this equation 2, you can say equation 2 n equal to 2 to the power k. This is equation 3, you can say. Okay, next k is log n base 2 into 1. Done. So 1 1 this side. This is how we reduced. Okay, t of 1. As for the t of 1, it is the value is 1 log n base 2. You can remove this one also. This is a constant basically. Okay, though we are actually running the theoretical model, that's why we are removing the constant. Okay, 1 plus log n, and indirectly we can say the time complexity, the tn is log of n plus n, or you can say constant is getting multiplied plus c. This is what the value of t of n. Now the time complexity you can directly say is big of log n base 2. This is the theoretical answer, but sometimes if the answer you need to be correct, like a gate type question, so here you have to write constant is actually multiplied with n plus a constant is added. This is what the result you can say. But it is theoretically correct and it is practically correct. Okay, so here we got to know how to solve a simple recurrence relation using iteration method. Next method we can go we can take an example of, suppose the same example. I'm just changing the cost of it. Okay, suppose it's tn minus 1. We kept the decreasing one in this way. Next, simple one. Okay, so here we have actually focused on the division function. Here we are using the decreasing function. How it is running that? Okay, the unknown term is n minus 1. To put that value in n, here only n, so n minus 1 minus 1 plus 1. Do not change the cost. Its cost is not getting changed if you are changing the n value. You are just putting n minus 1 in place of n only. Okay, then t n minus 2 plus 1 you are writing. Done. So like for to get t n minus 1, you should know what is the value of t n minus 2. That's why we are trying to find out t n minus 2. So you can put this tn minus 2 in n only. Do not change anywhere, because we are actually changing in n, then only we are getting the value. Do not change in n plus 1. The previous is not actually playing a vital role. In n we are actually trying to run. So n minus 2 and minus 1. Why? Because here we changing that one. Next one as it is you keep. Now tn minus 3 plus 1. This is how we are getting the answer. You can collaborate everything and you can iterate within a same one by substituting that value. Okay, this is not exactly the substitution one. You remember, substitution method is different. You can check our video list there. Okay, and iteration is different. Iteration, we are iterating by putting one value. Substitution is different. We are taking guesses there. We are using mathematical induction, because in core man it is clearly mentioned in divide and conquer approach. The substitution method we are applying to guess it first. Once it is proper, then perfect guess is also needed. It is there in a recorded video there. You can please view that one. Okay, then only you can be having the proper difference between a substitution and iteration one. Here the tn I'm just running within this one single function, tn minus 1 plus 1. The value of tn minus 1 is that you found here. Okay, the total value which you got, you put it here like tn minus 2 plus 1, then outside plus 1 you keep as it is. Okay, now you simplify. Tn minus 2 plus 1 plus 1, or else if you want to simplify, I'm just writing that one also. Tn minus 2 plus 2 into 1, I'm just writing that one. Okay, now you check to know this value. Okay, we are using this value directly because it's a value of tn minus 2. Tn minus 3 plus 1, then 1 plus 1 is there. Okay, don't be confused because I'm just multiplying here. Okay, you can say it's better I'm just removing that one. Might be it is confusing. Okay, if it is confusing, so look at here. Okay, done, clear. I'm just putting the value here, tn minus 3 plus 1 plus 1 and plus 1. Okay, now our target is to find a pattern. Without a pattern we cannot solve it. Okay, now you check the pattern. The pattern will be, here I am getting 3, here I am getting 2. It could be similarly written as tn minus 2 plus 2 into 1. So here 2 and 2 are common. You can say tn minus 3 plus 3 into 1. Here 3 and 3. If it is running for k times, similarly we solved for k times. For k times, t of n could be written as t of n minus k. Okay, I have to write the condition, the base condition, t of 0 equal to 0. Suppose the base condition is written as this base condition. Okay, t of 0 equal to 0. So here plus k into 1, I can write this one. Next, what assumption we have to take that we have taken recently? Assume we reached the base condition. Assume we have reached the base condition. Okay, then what we have to do is the function. What the function is? The Tn minus k is equivalent to T of 0. Why? Because base condition T of 0 we represented here. Okay. Next, I told you within that value will be equal to there. Otherwise, it will be not equal to sign. Okay. Now n equal to k. This is what we found. Then we substitute. Suppose this is equation 1 and this is our equation 2. Now we substitute the value of equation 1 in equation 2, or you can say substitute the value of k in equation 1. Okay, in equation 1, if I'll substitute, then I'll find the time complexity. T of n equal to T of n minus k ke jagah you have to write, in place of minus k you have to write n. Now n into 1. Okay, so n got cancelled, so T of 0 you have to write plus n into 1 you can write. Okay, next T of 0 is 0 as per the base condition we have written here. For the base condition T of 0 is 0. Okay, so then T of n will be written as 0 plus n into 1. So the time complexity then, time complexity theoretically it is big of n. Theoretically it is right, but practically if you could say c plus c into n, it is also right. Big of c is getting added with the constant is also getting multiplied with n. You can say if it is being said by you, it is also correct. Okay, but in theoretically we are saying big of n. Okay, so here what the note we should have to write, how to go for the approaching of this iteration method. First, the unknown term, step 1, the unknown term should be expanded, should be expanded. Clear? We have to expand that one, and then we have to find a pattern to be found out. Once you found out the pattern, next step is to assume and solve the time complexity. Okay, and find time complexity. This is how the steps we are following. Okay, I hope it is understood by you. If any problem, you can message below. Okay, thank you all of you to watching this. Thank you.